Hello everyone. Our IPD topic was Transforming Textual Tales, a comprehensive study on video synthesis. This is the agenda for today's presentation, and starting off with the introduction. We all have watched a lot of cartoons in our childhood, and of course everyone did have their own favorite cartoon character. Now imagine that your favorite cartoon character is into a scenario or an environment of your own choice. Yes, that is possible. So if you want your own favorite cartoon character to be in a space, a desert, a forest, this is what our IPD project is: converting textual prompts or stories into visuals. Here you can have a look at the frames that are generated by our prompt. Moving ahead to the summary of our literature survey. So while going through a lot of research papers, we found out that there are two approaches to go about with this project. First was to convert the direct textual prompts into videos, and the second was to convert the textual prompts into images and then convert those images into the videos. We have basically opted for the second method, that is converting text to images and then those images into a video. We have done an analysis of the literature survey, and we found out that there are three important criteria on which the video quality depends. First of all is the performance evaluation, which consists of the FVD score, the KVD score, the clip score. Basically, these are the scores that tell us the similarity between the images and the prompts. Second is the context evaluation. This context evaluation is another important factor which tells us whether our story is following a context throughout the generation of the video or not. And another is the length of the prompt. The length of the prompt also determines the generation of the video, whether the video is clearer for more length of the prompt or not. So these were the three important factors on which we did an analysis of a literature survey and went through a lot of papers.
Adding on to what Hia said, while going through all these research papers, there were three major research gaps which we had found out. First was the fine-tuning limitation. The model used in all these research papers were pretty generalized. They didn't generate a proper comic video which we were hoping for. Second, the contextual gaps. Maintaining the context of a story is very important in storytelling. So, for example, if I'm saying that Chota Bheem is jumping into a pool and he is swimming, so the he mentioned is Chota Bheem and the model needs to understand that. Third, motion omission challenge. The length of the prompt also played a major role in the quality of video generated. Sometimes, in some of these papers, if the length of the prompt was too long, then the model would get stuck on the particular line, and then instead of creating a video, it would create a GIF, which was a major problem for video generation. Moving on to the problem definition. To create a very engaging comic video is a bit difficult from textual prompts, right? The model needs to take care of the narrative styles, the artistic expression, and the intention behind the whole story. Our major aim of this project was to bridge the gap between textual prompts and the video storytelling. And second, the last point is to make a very user-friendly system so that people can use it without going through a whole hassle and generate a video. And they just have to write a textual prompt and then whole video is generated in some time.
This is a system architecture in which user prompt is taken and passed to the co-reference resolution model, which helps us to maintain context throughout the prompt. This prompt is then broken down into multiple smaller prompts which are passed to the fine-tuned stable diffusion model to generate frames. After the frames are generated, it is passed to Google's large interpolation model to generate a video file. The story taken by the user is passed to the Google's text-to-speech to generate an audio file to have a final multimedia output video. Co-reference resolution model. This model is used to maintain context throughout the prompt. So, over in this example, you can see I voted for Trump because he was most aligned with my values. In this, the model doesn't understand what the pronouns are, what are the subjects of the pronouns. So, with the help of a co-reference resolution model, we identify the subjects of the pronouns and then replace it with them so that the model understands. In the stable diffusion process, it selects a latent representation of a noisy image which is passed to a denoising autoencoder. What this autoencoder does is it detects the noise present in the image and is removed from the latent representation. This procedure happens for t times, and the entire process is done under the textual guidance of the prompt given by the user. This helps us to generate an image. We fine tuned the stable diffusion model with the help of Chota Beam images and these hyperparameters. This is Dreamboot's fine-tuning method in which the model is fine-tuned with the help of new subject and new images. So what the equation states is that it retains the knowledge of previous classes and adds the new knowledge of the subject instance given to it with the help of relative weight that is assigned. In this slide, you can see Chota Bheem in space created by our custom model and the stable diffusion's generalized model. Over here, we can see that our custom model has adapted some of the features of Chota Bheem. In frame interpolation, two images are taken and their features are extracted. With the help of these features, we generate a mid frame, which is the frame between the two input images, and then merge them together to form a final video.
Okay, now moving on to the result analysis. So basically we have done a result analysis on the clip score. Basically it is a similarity score between your textual prompts, that is the input, and the frames generated by the model, that is the images. So basically we have done our testing on 5 different kinds of prompt, and each prompt has been taken into consideration with 3 different types of length. So we have a prompt that is of length of line 1, line 3 and line 5. So here we have done a comparative analysis of the normal stable diffusion model that was created and our custom fine-tuned model, and we have analyzed that after fine-tuning and applying all the necessary steps onto it, our custom model has a higher clip score than the stable diffusion model. As you can have a look at the table. Moving on to the next slide, we have a small demonstration of our video generated by our model and the original stable diffusion model.
This is the output with using a generalized stable diffusion model. This output is given by the stable diffusion model, which was fine-tuned on Chota Beam dataset.
It was a bright and sunny day in the lush forest Chota Beam. The brave and adventurous young hero was out exploring the wilderness.
Alright, moving on to the conclusion. We have accomplished all our research gaps, like maintaining the context of the story with the help of co-reference resolution. We have also integrated our fine-tuned custom model with Google Films to make a better video generation, and that is a robust solution. We have also used our clip scores to ensure that the videos generated are accurate and are good enough. Moving on to the future scope, this project is very useful as we are just converting simple textual prompts into a video, which is great, to be honest. We don't really have to train it on just Chota Beam. We can train it on different topics and get better videos. This model can also help the story writers understand how their story is going and visualize it, which is so much better for understanding. This model can also help children get a video-based learning, which can enhance their learning capabilities and a lot more. Thank you so much everyone for watching this, and this is our whole IPD project. It was done by me, Aryan Tatrid, Athar Salian and Hiya Jain. Thank you so much.
अतः ये चाहिए तो लास्ट पार्ट एडिट कर देना, मैंने ऐसे ही बोल दिया है.